All right, and once again, if you just joined, reminder that it takes me about a day or two to input your attendance, and then you are responsible for printing your own certificate. So this professional development is called Engaging Students in Three-Dimensional Science Investigations using a Gather, Reason, Communicate lesson for middle school. We are going to walk through how you actually engage students in this sense-making process. It's very similar to the 5E model, if you're familiar with that. My name is Rebecca Gorelli. I'm the Science and STEM Specialist here at the department. And there's my email if you ever need me. And let's take a minute to introduce yourselves. I'd love to see who's with us. If you could tell us your name, your current position, what county you're in, because we like to track that data, and how did you hear about this PD? That would be great. So take a minute, introduce yourself in the chat. Thank you so much. The website, thank you. Perfect. All right, thanks, Danielle. Thanks, Stephanie. Nice. Thank you, Leo. All right, let's come in. If you just joined, I'm going to put a link in the chat that you need to just click and make a copy. And we're just doing introductions. My name is Rebecca Gorelli. I'm the K-12 Science and STEM Specialist at the department. Take a moment and introduce yourself in the chat. All right, and as you're continuing to do that, thank you so much. I'm just going to gently push us forward because this is a very timed out webinar. And let's get everyone familiar with this webinar resource dashboard. So this is the link that I put in the chat. So if everybody can make sure that they have that open and making a forced copy of that, that way everybody has their own copy of this and we're not all trying to work off of one document, which can overload Google. So let me explain how the dashboard works. And if you've been in one of my webinars before, we use a dashboard every single time. It's really just where I put all the resources that I use to create this webinar from scratch. And then there are some color coding that we need to talk about really quickly. Let me blow this up real quick. So at the top, this is how you contact me if you need anything. We have links to our main science standards page, our resource page, and registration for webinars. I do give you a PDF of this exact slide deck. So we have general resources, and then you'll notice they're numbered on the side. So I might say to you, open resource 1 or number 7, etc. And then the grade cells are the ones that we're actually going to open and we're going to use. So you need to have this dashboard up, as I mentioned earlier. If you can kind of minimize your Zoom screen and then minimize your Chrome or whatever browser you're using, that might be the best way to do this because you're going to go back and forth. And so really the white cells, the ones with the white background, are just extra resources that we're not going to open, but the gray ones are the ones we're going to open. So once you have it ready and you are done, just type done in the chat. So I know you have this document, you understand how it works. These are just clickable links and you are ready to go. Done. Thank you, thank you, thank you. Perfect. Thank you. All right. And if you're not there yet, hopefully you'll get there because we do need to gently move forward. I'm just going to invite you to read over our goals for today. All right, so this is everything we're going to do. We're actually going to engage in a lesson. I'm going to be your teacher. You're going to put your student hat on. We're going to start by talking about where did I find this lesson and how can you find lessons that support sense making and three-dimensional instruction. And then we're going to go into and you're going to engage in the lesson as if you were a student from start to finish. So here we go. If you go, I want to show you this amazing website of this national speaker named Brett Molding. He's actually come to Arizona 2 times now to build lessons that are actually on this website with educators. And so this is a website that he has created with free open resource lessons. So I want to walk you through how I found a lesson today that actually aligns to our Arizona Science Standards for 7th grade. So if you go to number 3 in your dashboard and you click Going 3D with GRC main website, it will take you where you need to go. So I'm going to ask everybody to go here. And then if you want to save this, I highly recommend bookmarking it as I did. So here's the landing page. And these are all, once again, open resource free lessons that are built using 3-dimensional framework thinking. So they will fit with our standards. However, you have to do a little bit of legwork because they're aligned to the next generation science standards. And I'm going to show you how to actually do that in just a second. But just to get familiar with the page, where we're going to go, you can either go up here to the top where it says middle school lessons, or go right here to middle school lessons. Either way gets you to the same place. So let's click middle school so I can show you where I found this. And our topic is life science. I can either go here or I can go here, get you to the same place. So I'm just going to open life science. And it'd be great if you could do this as well. That way you understand where to find all these amazing lessons. Now, the tricky part is on the left-hand side, you will see coding. That coding is not Arizona coding. That is coding for the next generation science standards, which are national. And this is a national website. Now, when you scroll down, the lesson that we're actually using that I sent you, maybe you had a chance to look at it, maybe not, doesn't matter, is right here. We are going to be using green leaves. And what I love about this website, it gives you the correlated NGSS standard, tells you which state of educators actually built these. It's got your lesson topic and right here, phenomena. Simple phenomena that we're going to figure out together. And then it's going to tell you the kind of approach. A lot of these follow the 5E model, so engage, explore, explain, elaborate, evaluate. And some of them are just GRC. GRC is very much 5E, so it's not like they're completely different. So this one actually has an additional accompanying lesson that includes some language acquisition. So I did incorporate some of that into the lesson that we're going to use in this presentation, but I just wanted you to know that these 2 lessons actually go together. This one just has some sentence frames and language supports. And so this is the one that we're actually going to open, and it would be great if you could have this out the whole time. So I'm going to show you how these lessons work. And if you just joined us, which I see someone just came in, please open and make a copy of this link. And this is the lesson. So I would love for everybody to kind of focus on looking at this lesson. Now at the top of these lessons, you have coding. You'll notice that there's 2 bundled standards that this lesson has students work towards. So it's a bundled lesson. And it's got the entire script of what you do with students, but I want to show you one thing all the way down. This yellow box here. This is something you're going to see in my presentation over and over and over again. And the reason why is because this is for the student. This is like something you can screenshot and put on a slide and only show kids piece by piece what we're doing now. What comes next? Okay, we did this, now what comes next? Okay, and then move forward, step 5, step 6. So this is actually prompts for the students. And this is something I put on slides and you're gonna see over time. So this is the lesson we're going to use, and I'm going to engage you as students through this entire lesson as best we can in 75 minutes. So I just wanted to orient you on these amazing lessons. I linked those 2 lessons that I just described also in your dashboard, just in case you just wanted them right there. Okay, so let's talk about what we just saw. We saw that this coding was there. Well, all of these lessons are connected to the next generation science standards, which Arizona is not an NGSS state. So that means you need to do a little bit more work to see if this lesson will actually fit with our standards, which I've already done that work, and I'm going to show you how I figured it out. So here, I can see in a document that I'm going to show you is that the coding MSLS1-2 for NGSS actually does correlate to one of our 7th grade science standards. And I'm going to show you where I got this information from in just a second. So just to remind you what we saw though, this lesson has 2 NGSS standards. These are called performance expectations in the NGSS world. We call them standards. So this one actually correlates to 7th grade standard 9 in Arizona. And this one that is bundled in this lesson actually correlates to standard 12. So it actually meets, kind of connects with 2 of our 7th grade standards. And so how did I know this? Well, we have these amazing tools that I want to show you. I'm not sure if you've seen these yet. These are called planning summaries. And if you go to number 4 in your dashboard, and if you just joined us, welcome. I'm going to put a link in the chat that you need to copy, which is what I'm showing you on the screen. And those of you who are with me, go ahead and open K-12 planning summaries. These are all on our website also. But what this is a tool for you to look at and say, I know what the NGSS coding is for this standard. I found this resource and I want to see if it'll actually fit with the Arizona science standards. And so here we go. As we scroll down, there's some front matter that talks about the shifts of instruction in 3 dimensions, but really where I want you to go is starting on page 4. This is where our standards begin with kindergarten. Now, we are all the way in 7th grade. So I'm going to scroll, and please forgive me for scrolling, all the way down to 7th grade. This is K through 12, but on our website, if you're just looking for 7th grade by itself, we do have them listed and taken out by grade level. Like you can just click on kindergarten, 1st grade, 2nd grade to get these, but this is the full package. Now, why is this important? Well, on the left-hand side are all of our Arizona science standards. On the right-hand side are the next generation science standards that actually correlate to our standards. In the middle, you will see some coding. And there's a key up here that explains what that means. So let's go to the standard we're actually looking at today. Number 9 is right here, and I'm on page 23 in this PDF. Hopefully you are with me. Now, this is construct an explanation and then read the rest. It has a P here. What the P stands for is partially correlated, which if I look at the key, means the core idea, the content is very similar. The science and engineering practice may or may not match. If it had an S, it would mean both the content, the core ideas, and the practice, the SCP are exactly the same. If there's an NC in the middle, it means they are not aligned, therefore probably don't use this resource. So for us, we're looking at number 9 right here because that correlates to MSLS1-2. And if you remember from the lesson, MSLS1-2 is in there, and also NGSS number 6 for Life Science 1. And if I'm going too fast, I apologize. But this is how I figured this out. I found the coding from NGSS, looked to see if we had a standard. I found the other coding, looked to see if we had a standard. I have a partial and a partial, which means I might need to tweak a couple things about the science and engineering practice, because here it's construct an explanation. Here it's develop and use a model. Those are different. Here, construct an explanation, construct a science explanation. Pretty similar. And then when I read the content, we're talking about plant cells converting light energy into food energy and cell structures and functions. So this lesson is going to combine all of these things. I hope that is crystal clear. I hope I explained that okay. All right, so that's how I knew, like, is this lesson actually going to work? And the answer is yes. Might have to tweak a couple things or combine some science and engineering practices, which I did. And again, just to make sure everyone understands how to read our standards, L1U1 is the core ideas. L1 is right here, organisms, this really big idea that organisms are organized on a cellular basis. And then we have this one, which actually comes from L2, which is organisms require a supply of energy and materials. These big ideas that we're going to discuss a little bit of. So there's the breakdown, and U1 just means I'm going to engage you in phenomena, and we're all going to try to figure it out using the 3 dimensions. And so what are those dimensions? Now that we figured out the core ideas are L1, L2, life science, U1, science and engineering practices, you are going to engage in constructing explanations, questions, obtaining, evaluating communication, developing and using models, engaging in argument from evidence. We are going to hit each and every one of these. Now, cross-cutting concept, the lens through which we think or gather information about the phenomena, we're going to look at patterns, systems, and structure and function, mainly patterns and structure and function, which directly correlate to these standards. And so, as a reminder, when you look at our standards, so for example, this is the standard we're going to progress towards today. This is kind of what we're going to learn. When I read this on the left-hand side, it's very important that I know on the right-hand side, this is all verbatim research from the documents used to create the standards on the left-hand side. This is not a checklist of what I'm supposed to teach. This is not everything I'm going to be teaching you. This is research for you to understand what does this standard mean and where did it come from. If it has an in-text citation of a number 2, that means it came from this research document, working with big ideas of science education. If it has an in-text citation of 4, means it came from the framework, which is what the next generation science standards was also built upon. Because we use this other document, that is the main reason we are not an NGSS state, because we pulled in ideas from this document as well. So, if you want to learn more about the gather, reason, communicate approach to sense making, I recommend purchasing these 2 books by Brett Molden, who is the educator who developed this website, who came out to Arizona twice now to build some lessons with us here. So these books, a link to them is in number 1 in your resource dashboard. So I would like to invite you to read over, what is this thing called GRC? Well, here it is. We start with gathering. That's our first thing. And these are the science and engineering practices we can use to gather information. Once we've gathered everything we can, we have to make sense of it. And we move on to the reasoning. And here are some practices we use to reason. And then once we've figured some things out, it's time to communicate what we figured out. We have to now hold true to what we believe and commit to our thinking and communicate that reasoning. And here are some practices to engage in. And this is an instructional approach to 3-dimensional teaching and learning. So how do you actually start this approach and how do you use phenomena with it? Well, first thing I'm going to do is I'm going to engage you in observing a phenomenon. We're going to do this together. And then I'm going to provide some opportunities for you to develop questions that have a purpose. Not asking questions for the sake of asking questions, but because we need to do something. We need to investigate what's causing that phenomenon to happen. If you've been in one of our other webinars, you know we try to drive home the message that phenomena are the effect of what you experience. It's the effect. You can observe it. It's an observable event. However, our job as science educators is to help kids figure out what's causing that phenomenon to happen. So our questions need to be explanatory and have explanatory power about how or why something is happening. Once we engage in questioning, then we'll move on to gathering information from a variety of sources, whether it's an article or data table or etc. We're going to start to reason and analyze the data, and then we're going to communicate what we figured out. And that's the process. And we do this because we want to motivate students to then apply everything they did and made sense of outside of the classroom. That is the ultimate goal. And so let's take a look at what you all are going to do. As I mentioned, this is the student prompt. There are these things called performances. You will see group performances. That means we do it together. We do not start off by just having you work alone. You might think by yourself first, but then you share with somebody else. So we have performances, which is an active participation engagement thing. We're going to be doing stuff together. We're going to continue with group performances. Then down here is when you have the individual performance, where you're going to engage in sustained silent writing. So this is a little bit of a flipped idea. We're flipping instruction upside down, where we do all the group thinking together. We're going to have a class discussion, connect to each other's ideas and collaborate. And then when it gets time, you're going to tell me by yourself what you figured out. And that's going to be the evaluative part. So it's a little bit different than traditional style instruction, but this is the approach that matches our standards very well. The blue, all of the things you see in blue and in all next generation science standards documents, blue always means the science and engineering practices. As you can see, we're going to be doing a lot of practices, because as you know, when you engage in one practice, you naturally will engage in many throughout your sense-making sequence. Green refers to the cross-cutting concept, or the lens through which I want you to think or gather more evidence to help support your sense-making of that phenomenon. So let's get started. I asked you all to bring leaves. Put yes in the chat if you have your own leaves. Just like, yep, I got mine. If not, don't worry. I took some pictures. All right, Stephanie, thank you, thank you, thank you. Okay, this is gonna be more fun if you have it. If you don't have it, don't worry, I got you covered. Okay. Now, this lesson's a little bit different. I'm not gonna tell you what the phenomena is yet, even though I know you saw it in the lesson. But the beauty of this one is the kids are actually going to figure out the phenomena first, before I even say anything. So this one's really cool, so I picked this one. So here's what we're going to do. If you were with students, you would ask them to go outside in pairs and find 3 to 5 different plants with leaves. Can be any leaves. Okay, so what you're going to do where you are, if you have leaves, is you are going to make some observations. You're going to do some exploring. And you're going to look at those leaves carefully to look for patterns across all the different kinds of leaves. And then you're going to write down what you noticed in an STW table. STW tables are called See, Think, Wonder tables. Go to number 6 in your dashboard. And I've got a table for you right here. You're going to open this, you're going to make a copy, and it will be yours forever, and you're going to write in it. Okay, this is a pretty basic chart. We use these all the time. This is a very popular strategy with our standards. And if you don't have leaves, don't worry. I took pictures and they're on the next slide, but let me just explain how this is going to work really quickly. If you have your STW table ready to go, just type ready in the chat so I know I'm not leaving anyone behind. Ready, thank you. And if you need support, just ask a question in the chat. I'll do my best. So you should have the See, Think, Wonder table. Okay, looks like most people are ready. Thank you. Okay, now here's what we're going to do. You're going to carefully observe the leaves and look for patterns across all of them. But I only want you working in the C part right now. Like, what do you notice? We're talking about just observations, not what you think, not what's causing it, not what you wonder yet. Just live in this space for a minute. I'm going to give you 2 minutes in what we call the alone zone. This is a critical piece of sense making. You have to give students time to think by themselves first, instead of saying, turn and talk to a partner. You got to have time for them to construct their own thinking and commit to what they believe first before sharing. So you're going to go in the alone zone by yourself. And if you do not, we are just going to do this 2 minutes of alone zone. So if you have your leaves, you are free to start doing this. And I'm going to set a timer that you can all hear for 2 minutes starting now, just noticing for patterns. Okay. Now, if you don't have your leaves, I took some pictures of leaves I found outside. Here is the top side of the leaf. Here is the underside. So you may use these pictures to help you write some observations. One more minute to look for patterns across all 5. And of course, if you had the leaves in your hand, it'd be a lot easier to see. Much more fun. And you should be writing just in the C part of the table. Anything you notice. I see, I notice. What do you think is causing it to happen? Not what questions you want, just what do you see? And there's 15 seconds left. Okay, time is up. Stop this one. So now that you had alone zone time, you have your own, you committed to what you saw, you commit to the patterns you saw. Now it is time to now share that you all had think time by yourself. This is one way we provide access and equity for all, is that everybody has the same experience and everybody has time to think. We're going to move on to sharing our ideas now in a Jamboard space. And again, we're just talking about what you see. I see, I notice. Not anything about inferencing yet. So you're going to share your observations. So look over your observation. I want you to pick 2 things you noticed. And because this is a science and engineering practice, we're going to color and use blue for our post-it on the Jamboard. And if you've never used Jamboard before, don't worry, I'll explain everything. So we're all going to post on one Jamboard together. When the posting slows down, when the post-its start to slowly come in, then we're going to circle using the tool, one of the pens. We're going to circle an observation someone in your group noticed that you did not. So you're going to circle something new, like, oh, I didn't even think about that. I didn't even see that. Circle. And then check mark with at least one observation someone noticed that you did. So what did you have to say? Check. I saw that too. Circle something new. So how do we get to the Jamboard? Well, number 7 in your dashboard is where the Jamboard lies. So come on here, let's get in the Jamboard. Everyone should be able to edit in this space. There is only one frame of this Jamboard. And once you're in the Jamboard, say here in the chat. So I know you found it and you're good to go. Thank you, Carly. All right, 4 people, great, thanks. 5, great, perfect. Okay, so just a little tutorial here. Here is your post-it note, your sticky. And when you click it, just change it to blue and then write your noticing in it. And then just move it over to the side and let go. You're gonna post 2 ideas. So what I'd love to see is everybody post 2 ideas that you noticed from your noticing chart, your C chart. 2 observations, and then I'll explain how to use the pen tool and everything else. So come on in and show me 2 of your observations. What did you notice about those? And then just scoot them over to the side and let go. Perfect. And you may make 2 if you can. So we see some veins on the other underside. Some leaves are smooth, edges and jagged. Great. Ooh, center vein down the middle of the leaf. Nice. Somebody noticed the top sides of the leaves are dark, undersides are lighter. So if there's 13 of us, I should see at least 24 Post-its coming in. If everybody can participate, that would be great. Tiny veins that make polygons inside the lines. Nice. And notice that leaves are all green. Nice. Okay. Some are pointed at the apex while others are rounded. Pointed. Width is greater. Middle of the leaf. Okay. All right, and now what I'm going to do is I'm going to start making categories. Let's see, some are pointed. These are kind of, let's see, veins. Let's get a category for veins. And please try to get 2 Post-its. This is going to work a lot better. And we're going to have more data, the more Post-its you guys can put in. So if you've already put one and you've got another observation, please put it in. These are green. We've got veins. All right, we got a category of veins happening down here. Veins. We're noticing some things about veins. Great. These are different size. These are different sizes. We got some coloring here. The top sides of the leaves are darker and the undersides are lighter. They're all green. The width is greater in the middle. We got different sizes. We got waxy. All right, so these are all things about the texture and size. So some qualitative observations here. We got pointy shapes. So we got some qualitative over here, some stuff about veins here. Continue to make some observations. Continue to make some observations and post them if you can. Looks like it's slowing down. All right, let's move on. Grab the pen tool. I was hoping to get more Post-its just because it's better with more data. No big deal. So grab the pen tool. You can pick any size pen, any color pen. And what we're going to do now is the directions are to circle at least one observation in your group noticed that you didn't. So you're going to circle something new, like I really didn't even think about the apex, quite frankly. So I'm going to circle a new idea. And then this one is something I totally noticed. So I'm going to put a check like, yep, I saw that too. So take a minute to look at each other's ideas and get a sense of what we all saw as a class. Circle things that are new to you, check mark for things you also noticed. I have some data here. Looks like a lot of people noticed this one. Top sides of the leaves are dark and the undersides are lighter, and that they were all green. That's some good data. Okay. All right, thanks. All right, so we got some folks that didn't really think about tiny veins. Okay, so the reason I wanted to show you this is these are tools you can do with kids. Even if you're in person, you can have them go on a Jamboard, right? And have them collaborate, connect with each other ideas. Very simple way to do that right here. And what I want you to look at is the data of what you guys are telling me. I'm going to use a different color. Let's go green. Look at this. This, based on these check marks, tells me data. It is telling me that you all, or at least, the majority of people who put check marks on things, that this is the one you notice the most. So I want everyone to look at your leaves. If you didn't notice this, do you see it now? Does the top side of the leaf look darker than the underside? Just think about it in your mind. Here to guide your mind. And so now I'm going to come back to the presentation, because that's what we're doing next, and I'm going to exit real quick so I can take some notes. What I just noticed is that many of us saw that the top side of the leaf is darker than the other. That is the main data that came out of that sharing. And so now that we've kind of talked about that a little bit, based on those patterns, what are your predictions? If I go outside and I grab another leaf, do you think this pattern will continue? So at the bottom of your See, Think, Wonder chart, go ahead and make predictions based on the observed patterns. And you're going to write right in this space. Is this pattern going to continue if I were to walk outside and grab leaves from a bush or a tree, or find some on the ground? So right now, take about 30 seconds to make a prediction on your own. And if anybody wants to write their prediction in the chat, please do, just free chat. Go ahead and share your prediction. Will this pattern continue? Yes or no, why or why not? What are you thinking? And so we just moved from making observations of patterns, that's the lens through which I asked you to look, to make predictions. So if anybody wants to share a prediction, go ahead and put it in the chat. If not, that's okay too. We're going to just keep moving along. All right. So now that we've done some noticings, we've done some predictions, now we're going to move on to what do you think is causing that to happen? Here's the phenomena that you actually all just saw. The leaves are green. We all saw that in our data. Lots of check marks on that one. However, the top side of the leaf is a different shade of green than the bottom. So that is actually really cool because the kids get the experience of figuring out the phenomena and noticing it. A lot of these lessons don't have that included. Some lessons just start off with the phenomena. So now that we know the phenomena has to do with the coloring of the leaves on one side versus the other, our job now is to think, what do you think is going on? Do you know anything about this? What do you think is causing it to happen? And then we're going to move into asking questions based on those patterns. So now we're going to go into Think Wonder section. I'm going to give you 3 minutes to type in here. What do you think is going on now that we notice that pattern? What might be causing it to happen? And then try to develop questions in this wonder box. And we always have a purpose with asking questions, to obtain information about the patterns they observe of the leaves being different on the top than the bottom. What kind of questions can you ask to help you figure out why is that happening? So I'm going to leave you alone for, let's just do 2 minutes for the sake of time. At least have 1 or 2 questions. So I'll set the timer for 2 minutes. To do some thinking and some wondering. And you should be in your See, Think, Wonder table. We are working on the think. What do you think is happening? It's causing it to happen. And then what questions do you wonder? What questions can we create that can help us gather information about why that pattern is happening? What questions can we ask to get information? And hopefully you are writing in your think and your wonder box. There's about 1 minute left. And again, the alone zone is time for you to think by yourself before you share with anybody. We will share in a minute. Okay, there's 20 seconds left, but I'm definitely behind on time, so we're going to get moving. So what we're going to do now that you have thought about what you think is causing it to happen, what questions do you wonder to help you gather information about why that pattern is happening? Let's share. And we're going to do a waterfall. And the way a waterfall works is pick one question you think can help us make sense of that phenomenon. Pick one of your questions from your Wonder Box and type it in the chat, but do not hit enter. I'm going to give you 30 seconds to type that question in the chat. And then when the timer goes off, I'll say 3, 2, 1, and we all hit enter. So right now, you're typing one question into the chat box, but do not hit enter because we're doing a waterfall, which means you all hit at the same time and your answer is waterfall in. There's 11 seconds. Okay, time is up. I'm going to say 3, 2, 1, hit enter. Perfect. All right, now I'm going to go look for trends in your data. All right, we're looking at maybe the difference is color has to do with photosynthesis. The color on the top have to do with sunlight. What makes it darker on top than the bottom? What if I block off rays of sunlight from leaves? Wonder if it, I see a trend so far. We have some folks wondering about sunlight. I've seen that 3 times now. Seems to me like you guys want to know about the sunlight. Excellent. Why is it darker green? Perfect. So thank you. So based on the trends in our data in the waterfall, it looks like most of you are wondering about what's causing that change and could it be sunlight? Good questions. Let's see if we can figure some of them out. So now we have done this part and we have done this part. We are now moving along in the lesson and we are still in the gathering process. We have not started to reason yet. We are still gathering information. So now we're going to gather some more until we're ready to make sense and start reasoning. So together, here's what we're going to do. We're going to obtain information from a reliable source to use as evidence for how the structure, cross-cutting concept, of the leaf structure functions to meet the needs of the plant. So what does this look like? Well, all of these lessons come with a reading in one of the appendices. As you can see, I took it right from the lesson and you're going to go into the alone zone, but I'm going to cut off some time here. Let's do 4 minutes instead. And how do you get to this article? Because reading is one way we gather information to make sense of the world around us. So this is awesome. We're going to go to our webinar dashboard, go to number 8. Here is the article. I made you your own copy. That way you can annotate as you wish. If you want to highlight, write comments, any of that. You're welcome to do that because you have your own copy. So we're gathering information for a purpose though. And here it is. Our goal is to look at through this reading. Yep, there we go. All right. We're obtaining information from a reliable source about the structure of the leaf and how it functions. The structure and function is the cross-cutting concept here. That's the lens through which we're going to gather more evidence. As you read, think about structure and function. You might want to highlight structures, what they do, any of those things. So this is one page. And if you want to click on these, you can, but really let's just get the reading kind of done and annotate it however you feel comfortable. But again, remember, this is for a purpose. We're gathering information about the structures and the functions to meet the needs of the plant. So alone zone by yourself for 4 minutes. I'm going to take off 2 minutes, and you are on your own to read this information. And I'll set the timer. There is 1:45 left. And if you're looking at my screen, you can just see how I was annotating, highlighting, putting comments to myself. And if you are done reading and you're ready to move on, just put done in the chat so I know already. As a reminder, we were looking for structure of the leaf and how it functions to meet the needs of the plant. All right, so a few folks are done. And in the essence of time, I'm going to keep moving because I do believe I'm behind on time. Okay. And so that is part of gathering, very important to gather information from reliable sources. And each of these lessons has some sort of reading. Now, when you look back at where we are in the lesson, we've done all of these things, gather, gather, gather. Now, we are going to start to make sense of all the things we've gathered. And I bundled these 2 practices together because I love bundling them together. They are my 2 favorite practices to put together. Because when I develop a model, I'm going to use that model to construct an explanation. That's what develop and use a model means. I'm going to use it to explain. So they go hand in hand. Now that we've gathered, we're going to start to reason by constructing explanations about the structure. Think about this, the structure of the darker top versus the bottom and how it functions. And to do that, we're going to use modeling to show the differences in the structures of the top and the bottom. And you just read all about that. And now we're going to put it together in an amazing document that I made for you that I love. I hope you love it. I hope it's not overwhelming. go to number 9. This is a group Google Doc. So go ahead and open it. We are all going to be on the same doc. Now, obviously, this is a digital strategy, but sometimes kids like digital strategies for things like this. You can have them do posters for modeling, however you want to do it. But since we're in a digital space, I built a digital way to do this. So here's how this works. And if you can all look at my screen, that would be lovely. All you're going to do is you're going to go take a spot. So I'm starting at the top, and I'm going to put my name here because I did an example in that spot. So we're going to fill up all of group 1 first. We want at least 4 people in each group to the best we can. So pick a spot, take a spot, put your name in there, and then go on to group 2 and fill it in, and then group 3 and so forth and so on. Thanks. It's always fun to see your ideas come to life. Thank you. All right, so group 1 is ready to go. Let's try to get folks in group 2 and then group 3. Let's try to get full groups if possible. All right, so those of you who are in this space and found how to do this and figuring it out, thank you. Now, if you have a lot of students and you want to use this strategy, I built bookmarks here that'll directly take you to your group's model. So you can click on these if you want to, otherwise you can just scroll down. And here's what you're going to do. We always do the alone zone first. I need to consider and reason by myself first before I go and look at any of my group's models. So we are going to do a combo strategy of developing a model and constructing explanations because they always go hand in hand. They're my favorite. They're the best to go together. So here's how I built this. If you look at group 1, and this is the part where some folks get a little confused. So I'm going to ask that you all orient yourself to my screen so I can explain how you edit this document. What I have for you, and the goal here is to take everything you gathered from the reading, from the noticings, and now make sense of it and start drawing a model. What do you think is happening here? So we're going to develop a model to show the differences in the structures of the cell. You just read all about these things called palisade cells, right? And I wouldn't say this to students. I'm just guiding your thinking as educators right now. But what I would do with kids is I'd say, okay, now you've got to show me what you're thinking. What did you just read? Draw me a model of what those structures are on the top versus the bottom. And so to build documents like this, this is a Google drawing actually. So if you click on it, you'll see this box pop up, and which will open up this nice toolbar and you can edit. So when you get in here, it becomes a Google drawing. That is how I drew this. I made a little key. And once it actually starts working, this toolbar will pop up. Okay, so they have shapes, which is where I got circles. And then you can color them. You have text box, you can put in images, lines, all kinds of things. So what I did is I used these little circles to show these cells, and I made a little key about what those difference in colors mean based on what I read in the article. So every single one of you in your group, so if you're in group 1, you're going to be in my group in the green. To see how I put my name here, and this is my model and my explanation. Then the next person puts their name here. This is their model and their explanation. Next person, their model, their explanation. So just try not to take someone else's spot. Right there, it looks like it's missing. Just gonna add in, oops, sorry. For explanation there. And again, to edit this, you just click the image and hit the button edit, which will pop up right here. So I'm going to give everyone a moment to get set. So if you are in group 1, so Rebecca, Stephanie, Carla, and Suni will all be in this green group. Perfect, perfect, perfect. Group 2 looking good. Did not get in the groups. Okay, so let's see. We are in number, if you're into the dashboard. If you have the dashboard, we are in number 9. And if you open number 9, those of you who are already in there, go ahead and start constructing your models and writing your explanation. So there's the link. We are on number 9 right now. We are reasoning. So you just take a spot. Once you put your name in here, once you get into this document, which is number 9. And your goal is to go in the alone zone by yourself and do these 2 things. Develop a model, construct an explanation. No, your model, I just gave you an example. No, you're going to draw whatever you want. No, they are not supposed, this is not a copy the teacher thing. This is what do you think in your mind? Yep. And I'm just giving you an example just to show you how it functions, really. Depending where your students are at, I wouldn't give this to them all. I would just give them the leaves like I did for you guys. And say, decide what you want to do. Make your own key. Make your own, it depends on what you've taught them about modeling at that point in time. But yeah, that's just me showing you how it works. All right, so alone zone, let's set a timer. And if you need help, just ask a question and I'm here to help. Let's see, we'll do maybe just a couple minutes just to get you oriented to how this works. And I'm just going to come look and see how everybody's doing. Steven, nice. All right, we got some writing happening. You're making sense, you're reasoning. Thank you. Perfect. And again, remember, it's about the structure. What are the differences? I guided you to make sure you knew what to put in your model. Show differences in the structures of cells on the top versus bottom. Then you're going to explain how the structure on the top and bottom functions. Remember your prompts are very targeted for what I'm expecting you to do. Definitely fantastic. All right, so we're getting the process, making sense, reasoning. And again, this is digital. You can have kids obviously draw this, posters, notebooks. But it's important they all do their own first, then you can combine ideas together in a group consensus model. That's the style of instruction we're looking for here. Just by yourself first, commit to your own thinking, construct your own knowledge, then share. All right. So now when you're done, now that you've committed to your own thinking in your alone zone, now you move on to sharing and looking at each other's models. So I built in a strategy and an expectation for you. So if you're ready for this, great. If you're not, don't worry. My goal here is to give you a variety of strategies that you can do in the digital space that will also work well in person. So the next group, and if you're still drawing and writing and everything, that's okay. But for those who are ready, I'm just going to gently move you forward. What you would do now that all kids had their own thinking commitment on paper, right? This is my model. This is what I'm making sense of at this point in time. Now I'm going to go look at the other groups. First, I'm going to start within my own group. I'm in group 1. So I'm going to look for one thing that's the same and one thing different between my model and other people just in my green group right now. So I see something here. I'm just going to write a little note. So what I put over here are possible sentence starters. And you can do this with the comment function and have kids do this. One similarity is, one difference is. So I would come down and say, oh, I noticed here, right? So I'm just going to put a comment on. Oops. One thing the same is that I use dark green for more chlorophyll. And you just make comments on others. I did something the same, I did something different. And you use the comment function to do that. So this is one thing you can do with students, to have them look at each other's models, respond to each other's models. What do you notice? What do you wonder? That kind of thing. And then you ask one clarifying question. If I come down to someone's model and I want to ask a question, I just put another comment like, hey, can you please clarify? And so if you have time to do that, great. I know we're kind of running out of time, and that's okay, but I just wanted to show you some strategies of how kids can collaborate with one another and make comments on each other's documents. And you can do this in person with Post-it notes or any kind of strategy. The point is, this style of instruction is about going in the alone zone first. Let them have time to think before they share. That way, every single kid at the table has something to bring to the conversation. Then we can combine our ideas to build out a group consensus model if we wanted to. That usually comes next in the modeling process. Is we like these ideas, let's jam all of our ideas together, and this is what we think at this moment in time. So I am going to move us forward. This is just to kind of get your feet wet. I wish we had all day to do this, but we don't. I just wanted to give you some strategies of how we reason and how I bundled developing a model and constructing an explanation all in one. So now let's come back to what we're doing next. I would like, and we're not going to have enough time for this, but what would come next is we have a class discussion about those models. And I was going to teach you a digital strategy to do this, but we don't have enough time right now. Because we don't just want to have kids draw models and then not discuss them as a class, right? Like we've got to say like, oh, this group had these kind of models. So we would ask groups to, talk about what they put in their models, what they saw in their models, and that kind of thing. But we're going to move on since we don't have time for that right now. But we should have a class discussion, because now that you've started to reason, it is my job as the educator to continue guiding your reasoning. And if you're a 5E model person, like that's how you teach, this is the explain. We've already engaged and explored. Now we're in the explain. In this style of approach, it's called reasoning through class discussion. And every single one of these lessons has built-in questions. So here's how we're going to do this. This is going to be open chat. So whoever would like to answer this, go ahead and just put it in the chat. Now, if I were in the classroom, I would definitely use my talk move strategies and get kids to connect to each other's ideas by using talk moves and productive talk strategies. So here's our first question. What structure in plant cells causes the green coloration of the leaf? If you know the answer, go ahead and put it in the chat. What structure? Looking for the structure. And you gathered this. Okay, so I see someone said chloroplast. Chlorophyll. So let's go back. What structure? And let's think about what we drew in our models and go back to those models. And think about what we read in the article about structures that cause the green color. the actual structure. How does the structure of the top side of the leaf different from the bottom side? We're talking about structures here. You have an idea, go ahead and put it in the chat. Obviously, if I were with kids, I would do this in a way that connected your ideas to other people. So how does the structure of the top, how is it different than the bottom? Go look at your models. What do you see in those models? What did you draw? So if anybody has the answer to that or knows something from gathering through this reading or looking at your models, that's what we're looking for. I see chloroplasts and palisade cells. So we know we have chloroplasts inside the cell. They have chlorophyll in them. And then down here, the cells near the top are called palisades, tightly packed together. On the bottom, they are called stomata. So hopefully you annotated some of those thinking. I'm just guiding you thinking here. Why is the function of the top of the leaf different than the function of the bottom? Think about the function now. What about the function on the top versus the bottom? An open chat, and I'm just going to move us forward because we're running out of time. But we would have a very long, rich discussion with students because these are the things I need to help them reason through before they go back to their models and go, oh, I missed that. Or, oh, I forgot about, maybe I should put the sun in here, right? Maybe I want to add the sun to my model. Right, because I just saw Stephanie put in the chat, the top leaf receives more sunshine. Wonder if we should put the sun in our model. Maybe we do, maybe we don't. We decide together as a class. What is the role of leaves in the system, etc. So in these lessons, these built-in questions are there and they are purposeful. Because once we explain this with kids, and this is not me, Sage, on the stage, where I'm just going to explain all this stuff to kids. I'm not. I'm going to go back to the reading. I'm going to go back to their models and say, go look at your model. Use your model as evidence. Use your explanation. Use your patterns as evidence to help you reason through this. And then what we would do is after you have a rich class discussion and kids are connecting with each other's ideas and collaborating, you go back to your models. Because we just explained all of this together. We reasoned and made sense of this phenomena and the structure and function together. Now let's go back to our model and add in any new learning because we're reasoning. This is part of the reasoning process. So you revisit and you add to your model because when we develop a model, it's not just one model and done. We come back and we come back and we revisit because to develop means over time. And then to use the model, which it's develop and use models, constructing an explanation is how you use it. You're going to use that model to make an explanation that's going to help you make sense of the phenomena. And so now we have done all of these parts of the lesson. It is time for students to then communicate. Remember, it's G, gather, 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 reason, communicate is the C. And SSW stands for sustained silent writing. They have had a chance to think, reason with groups. Now it's time for them to perform on their own. And that is what you evaluate as the educator. So we don't have time for this, just wanted to kind of explain it though. Now you have the students just use all the evidence they collected from everywhere, from their See, Think, Wonder, from their Jamboard, from a model, from their explanations, from the class discussion. They have all these things. Now they have to write it. And again, explanations are causes of phenomena, but now we're moving into arguing from evidence, which is not the same thing as writing an explanation. Now I'm going to support my ideas with evidence. I'm going to use patterns as evidence, observations as evidence. And so in number 11, if you're looking for a scaffold for students, I made this. I used to love to use these in the classroom when I taught three dimensions. An evidence collector. Every time students have like collecting evidence, I had them put it in a one-stop shop when I was having them do engaging in argument from evidence. So what are the things you figured out from your See, Think, Wonder, from the reading, from the class discussion? That's for constructing an explanation. On the arguing side, if you've never done this before, to argue means you reason, you explain how that piece of evidence actually supports your idea. So you could say things like, one piece of evidence is more stomata on the top than the bottom, or sorry, more stomata on the bottom, palisades on the top. This is important because palisade cells have chloroplast and blah, blah, blah. So for evidence, I gave you some sentence starters. And then for reasoning, which goes with arguing from evidence, I gave you sentence starters. And these are things I've used in middle school for a very long time. They work very well, or at least in my experience. If your kids need additional support, you can always add sentence frames to help them. Both of these documents, or actually this is one document and it's number 11. So this is what they perform. And this is what you are evaluating. This is their assessment. And in the lesson, it will give you evidence of proficiency. What should the models have in it? So if you're wondering, like, well, how do I help kids know what to put in the model? Come to this and work backwards. Here's full understanding, partial understanding, limited understanding, and how you can act on the evidence of learning. If they have full understanding, they usually have some things you can do. If they have limited understanding, they usually have some things you can do to act on that evidence of learning. And so just to revisit, remember this entire time we were trying to figure out why the leaves are darker on top than the other underside. And really, this lesson, actually, there's leaf lessons all throughout this website that all relate to these Arizona science standards. So if you're not familiar with spiraling, our standards do spiral. And there's a lesson for each of these in that website. And I just want to remind you that the simplicity of phenomena through these lessons called GRC is incredible. Look how simple this is. Sometimes folks believe phenomena has to be this crazy phenomenal thing. It's not. Roots are green. Something causes that to happen. Let's go figure out why. Plant roots are hairy. Some are more hairy than the others. Let's go figure out why. Chicken feet are made of chicken parts. I taught this lesson not too long ago, and it really is about the structure and function of how a chicken foot works. So it's these simple things that happen every day around us, like leaves are darker on the top than the bottom. Something is causing that to happen. There's a reason. So I'm on for questions. We are at time. Thank you for allowing me to record this, and I'm going to stop the recording.